Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ziad Alashram. I have made this video for the IBM Advanced Data Science Capstone project course in Coursera, where for my project I have chosen Arabic Sign Language, image recognition and classification. For that, my use case is to build a deep learning model to recognize and classify images into Arabic Sign Language. For that also, my dataset is I have obtained 3 datasets. The first one is a set of images, around 54,000 images of Arabic, representing Arabic Sign Language, gestures of Arabic Sign Language. These images are categorized into 32 class category. The second dataset is the location of each image within the dataset directory. It's a compressed file, contains subdirectories. Each category is a directory, and this dataset have mapping around all the files with the class ID. The third one is the class label, where I have each class labeled Arabic and English. Preparing the dataset. When I first analyzed the dataset, I found out some classes contains images more than others. So to be able to equally train the model equally for each class, I decided to take same amount of images for each class. I have ended up with around 1,200 images per class, and these were splitted into prediction, fixed number 3 per class for prediction, training, and later on test and validation. This is the code to split the images, to split the data into 3 data sets: training, test, and prediction. Later on, to prepare the images to be fit to the models, I've created this function to deal with each image, with each data set. Resize the images 64 by 64, convert them to grayscale, convert the images to NB array, normalize. And for the case of the deep learning model, Keras CNN, later on we convert them to categorical as binary classification instead of integer. Last function is to display the class label. Since I have Arabic and English, I created this function to display Arabic and English, or English. Model definition. My first model I tried with k nearest neighbor. I will go through fast here. I have split the dataset to prepare the images. I ended up with the shape of training images around 28,000 images by 4,062 pixels, and the training set. I played around the model definition, ended up with this as a best outcome for the model, where the accuracy was around 94% accuracy. And here is the confusion matrix. As for the prediction, here's the prediction results. There is a lot of misprediction here, so we can assume, I can tell the model was overfitted. Now, the deep learning model, I choose convolutional neural networks, Keras convolutional CNN, with 35 epochs with early stopping, batch size the default 32, optimizer Adam. For the layers, convolutional 2D with 64 features, maximum pooling, dropout to minimize the overfitting or to prevent the overfitting, flatten layer to prepare it for fully dense neural network, and ended up with the classes. I need to categorize them into 32 classes. For sure, compile close categorical cross entropy, optimizer Adam, accuracy, and this is the summary of my model. For the evaluation analysis, here are the results. I already saved the model for later prediction or use somewhere else, and I trained the model. For model prediction, this is my outcome when I apply or when I try to predict the 96 images. Here are the results. However, I ended up with around 4 mispredicted results. Number 1, 2, 3, and 4. So I wanted to do more testing and prediction into model. I ended up with around 900 something, 900 plus images for training and other 300 for testing. It's not much of images for the model. So I wanted to do some more testing on live feedback. So I have created a Python script with the use of OpenCV, TensorFlow, and all the other libraries, NumPy, Python, NumPy and Pandas and Matplotlib. I have downloaded the model and test the prediction using other images, or a walk around the images where I was able to flip the image, change the background color to white and black. Since my raw images, some of them were in a background color, other in white background color. So I want to test all these cases and see how the model will react to them. I leave you with a video presentation for my test using the Python script. Hi again. So this is the output of the Python script, 3 windows. First window is a video output with a rectangular region of interest. Second window is prediction chart, where I display whatever the model predicts with percentage for each prediction. The third one is a small preview of the image that will be fed to the model for prediction, the final image, 64 by 64 grayscale. So let's give it a test. So this is Sheen. That's good, 99% Sheen, and there is La. Sheen and La are playing around. So to be able to do some further analysis and test, I have enabled some image modification, like here, flip the image to check the flip. Maybe the model was trained on more images, flip this way. So flipping is available. Second one, because I have images of black background color and some white background color, so I enable also to switch the mask between black and white. So for the black, 99% Sheen, nothing else. Let's check this flipping. Okay, Sheen 99. So Sheen looks good. Let's try Scene. Scene also look good. Let's try to flip it and see. So it seems model was trained more into images flipped this way than this images like this. Background color, calf. So let's try again. Sheen, calf, scene, good. Bat, flip to check out. Bat, that flip. Okay. Tap. Hat. So what I plan to do next is to try to flip all the images I have and switch background color and feed it to the model for training and check the outcome. Like now, this between Ta and Calf, between Ta and Sheen. Thank you. Here are the links related to my work so far. You can find them in the video description below. The first link is for the original image data set, the 54,000 images. The second link is for my Kaggle channel, where I placed the kernel over there. The last link is for the Python script I used for later on live prediction. Hope you find my presentation useful. Thank you so much.